Hi everyone, I'm Dario.
I'm Alex.
Hello.
How's it going? It's a beautiful day out in San Jose.
We're going to go quickly. I'm a developer evangelist for HTC, decades of developer experience, and we're going to talk about the tools of the trade.
I'm Alex Sink. I'm a developer. I have worked at many VR companies, and I currently do networking for a VR startup.
If you want to follow along online, we have this available, tinyurl.com/SVVR 2017-Roomscale. You can look at the slides, move ahead. If you're into a workshop mode and you want to do some coding, you can look at what we're going to do. Okay, this is what we're going to cover. We're going to just address opportunities for success. We're going to do an intro. There's many tools out there, but we're going to focus on three. The primary one being SteamVR, the first, of course. And then we're going to look at HTC or Vive Software's Vive Input Utility, and we also will look at the popular VRTK. And then we're going to do some live coding. And then we're going to talk about how to mix and match. We're going to compare them. We're going to talk about the future. Just to get things straight, we should define some things. So let's talk about what is Roomscale. I think it's primarily, as you can see in the picture, the ability to walk around in a space being tracked, and the interactivity that's provided with the controllers. It's the sense of presence requires those prerequisites. Here's an actual stress level 0, their actual setup. They've shared a lot. You should check out their videos on Roomscale and setting up rooms. These are stats from Valve, from SteamVR, and it's important to understand what you're targeting. And essentially, they took a poll, they took a sample last year, and then they took a sample earlier this year. It hasn't really changed much. Their conclusion is primarily that you should target, the most common is 2.5 meters by 2 meters, which is about 6.5 feet by 8.2 feet. Just keep that in mind as your target. Best practices. So we're here to talk about what not to do, what to do. You've probably heard a lot of these before. We're just going to expand on it a little bit and comment how things have changed since, because these rules are still being written and broken. And naturally, the first thing you have to avoid is motion and simulator sickness. The thing I always tell people is don't move the player, even though a lot of these gamers like to move the player. Don't accelerate. Always maintain frame rate. Actually, the first thing should be maintain frame rate. And there's a lot of things that you can do to avoid sickness. Everything from the type of locomotion to testing to reducing the field of view if you are moving the player. In some cases, show the nose, show world grid lines. There's a ton of things, and I've seen a lot of where it fails, where it doesn't fail. I know I described in the description that I was going to point out bad examples. I don't want to put anyone on the spot, though. So I'm just generally going to say what to avoid. Do you want to talk to this slide?
Yeah. The core principle of this is you should keep the audience comfortable. There are many ways of doing this, and we can go on ad nauseum, so we're going to cover just the basics. If possible, allow the user to walk around. That's the most natural thing. And if not, if you really need them to move around, currently the best practice is to get them to arc teleport, which is a form of teleportation where you point your controller at an area and you see a projection of where it's going to be. One of the harder things as a developer is building anticipation of what's going to happen in your virtual experience. In virtual reality, you have the ability to let the user do anything, but the onus is on you to let the user understand what's going to happen and to be able to simulate that out in their head beforehand. Build reference points around them. That's why some of the earliest experiences, and maybe one of the easiest targets to try initially, is a turret-based shooter, racing simulator. These are all things where the near field of view, you have reference points where you know the constant size, you can compare it to the rest of the world, and you feel at ease. The reason why you get simulator sickness is because you believe that you're moving while your other senses are telling you that you're not moving when your other senses tell you that you are. So you need to avoid that. The alternative to chart-based shooters where you have a near frame of reference is the faraway reference, where you have like a Tron grid. Not everything you use to determine depth and size is actually based in real scale. Sometimes it's just based on like, hey, you know that this pattern is reoccurring, like the Tron grid, and when those things converge, you get a sense of where you are physically. And ultimately, tests against users. There's a lot of funny cases. Horizontal versus vertical blinds can make people sick in certain scenes, so you just need to be very careful about user testing and scaling things. Another aspect is make sure that they understand your game before you throw them into a pit of despair. Well, I mean, like, everyone's figuring out how to use these things. They're great, and everyone maps them in different ways. And you know how to use your controls because you're developing it constantly. But let the user understand how to use your game before you put them against a life or death sort of challenge where they feel like they're failing. You want this to be a pleasant first experience, so let them opt in before the action starts. I mentioned arc teleport. A common technique is you take where you project out that image of where you're going to be, and you press a button, and then you move out over there. There's another funny thing where if you instantaneously move, your brain believes that there's something slightly wrong. And the funny thing is there's a slight psychological trick that completely smooths that over. You just fade to black for, even 0.25 seconds. It can be a very short period of time like that. And then that lets the user, before you move them. So you fade to black in 0.25 seconds, you move the player, and then you open up. Of course, dissolves and other sort of fades, I think, will start to evolve. There are links that cover this in more detail. So what makes for good or bad room scale VR? That's like a whole topic. I think that we can pick out examples. Job Simulator does a great job. They have an interesting room scale design where they have a fixed design, which solves for some of the, like, hey, I don't know how big the play space is. They just say, we're going to design for an experience this size. They go after that. Tilt Brush is a game where not a game, it's an experience where you draw in 3 dimensions. And you get to see this. It's a very Zen-like experience, and they use space in a really cool way. And if you need to, you can teleport around, but your primary way of moving around is...
So one of the reasons I put these on the list is because natural locomotion, which is just walking around the room, to make the best of room scale, I think that you should really think about avoiding teleporting. All of these don't use teleporting. Some of them added it afterwards. I know Tilt Brush added it. You have a footprints that you can actually click on. But initially, even Aperture Robot Repair, I enjoyed it more before teleporting was added, because part of the problem with teleporting is people will start using it and not walk around. And I saw that happen a lot with Aperture Robot Repair. So these are just examples of making the most of the room scale space.
And those limitations can be freeing. Like, limitations are the heart of creativity. The edges of the puzzle are the first ones you put together.
So if you want a complete list, not complete, but a thorough list, there's that link there. I recommend checking out this. It keeps growing every day. I keep hearing someone, quote unquote, inventing a new form of locomotion. There's running plays, there's walkabout, there's all these things. And it's something to consider, to do research and play as many games as you can before making this decision. Here's some more. Again, we're going to share these slides, so I'm not going to really go through each one.
So a lot of ways to do locomotion.
So here's the fun part. So here's what you're here for. Is we're going to start looking at what's available for developers. Even if as a pro, or even if you're just starting out or you're not a coder, you can start using these tools. As time goes by, there's less need to actually do coding. So we kind of I kind of grouped them in different groups. The two at the bottom there, they're strictly focused on non-developers. So there's just a drag and drop design type of tool. There's no scripting. You're kind of locked in, though, because it's not customizable. So we're going to talk about the major 3 that most developers are familiar with. Steam VR from Valve, that was the first one. When the Vive first launched, that was the only thing to use. It's very good for what it is, and it's still being used because even the other toolkits need it under the covers. The problem with Steam VR, of course, is to do this, a little code bloat for beginners to really understand and to do all the steps you need to be able to get the pose for an object, for example. You got to find out which is the tracked object, find the device index, and there's a lot of boilerplate code that caused these other toolkits to evolve and appear. So the Vive Input utility from Vive Software. So we were working on that in-house even before VRTK was released. They were both released around the same time in July last year. VRTK really took off. All kudos to Stone Fox for doing a good job in getting the word out. He's got a large community. But they're very different, and we're going to discuss and show you how to get started with each of them. So what about Unreal? I don't want to forget our friends at Epic. You should definitely check it out. Even if you're a Unity developer, just install it, check it out. Check out what they do with blueprints and do the hello world of getting started with Steam VR in Unreal. Just get a feel of what that's about. But we're going to focus on Unity because that's what we're here about. So Steam VR plugin, Valve has got another plugin as well, but we're going to focus on the Steam VR. And their latest version is 1.2.1. It was released fairly recently. One of the major features I like is in Unity that you can actually turn off the fact that they force you to turn on the Steam VR. In other words, every time you launch Unity, you'll get a pop-up, even if you're not connected. So now you can actually turn that off and work offline on the plane or whatever. Yeah, that was very annoying. When you're using just the Steam VR without any toolkit, it's generally what I've been saying for the past year or two is simply you drag and drop the camera rig into your scene, delete the default camera, and then you just run. So it's getting it up and running, seeing your controllers, and being able to walk around. It's really, Steam VR did a great job. It's when you start doing other things, when you start adding teleporting, start adding grabbing objects. They do have scripts so you can actually drag and get things working, but if you want to customize that, you really need more elaborate toolkits. So I'm going to talk about the HTC's offerings first. So we have 3 plugins, but I'm only going to focus on the Vive Input utility. So again, it's based on top of Steam VR, and it allows you to access the device status. It wraps the ability to get poses from controllers and now trackers too, in case you haven't seen one. So there's a different class of track device. It's just simply generic tracker as opposed to controller. So now we have to learn how to mix and match what controllers and what trackers are. So with our latest release, which is actually this week, we allow you to define a lot of roles to assign to these specific devices. Like if I want to do body motion tracking, I can say this tracker is going to be in my hip, this other tracker is going to be in my foot, and not worry about them getting confused. So we provide a tool to do that mapping. Also, for the controllers, we handle not just grabbing things, but also using them as pointers to select things from menus, that kind of user interface. So again, the whole idea is to reduce this boilerplate code, as you see on the top, to just a single line. So 3 lines become 1 line, but it makes a lot of difference when you're reading code and you quickly want to prototype and quickly want to get things going without having to worry about any of the prerequisites. So as I mentioned, we have this new tool. This is just out this week. So this allows you to, one of the problems with mixed reality, for example, I know I gave a talk yesterday about it, was the fact that you needed a third controller before this, and you had a problem every time you turned on the controllers, it would be assigned to a different index. With this tool, you can finally not worry about which order you turn them on. If you turn on the camera first, it knows it belongs to the camera, and you don't have to actually take it off. So it's a good, useful tool for those who are interested in tracking devices. So we're a little different in that from Steam VR, in that we wrap these controller utilities into our Vive rig, which includes the camera rig actually, and that provides all the code, probably more than what you need. You may have to disable things in the inspector, and we provide also the tools to do teleporting and so forth. And we'll show you some code later. How to make things grabbable. I don't know how you feel about it, but sometimes I feel like everything should be grabbable.
No, I mean, sound reactive and grabbable, this is part of the core wish fulfillment of virtual reality, is the ability to have something react in a way that you would reasonably expect, even if that's irrational, flying to the moon, etc. And physics is one of the core challenges. Things feel differently, just like for rendering when something's far away. In 2D games, in flat games, you basically have like really high resolution in the background, but in VR things need to feel really good up close, and that puts a lot of pressure on physics and a lot of other sort of paradigms for picking up objects, moving it around objects, and not having them fall down or do unexpected things. And a common toolkit is VRTK. This was put out by the Stone Fox, and he is providing a solution for wrapping multiple SDKs and remapping things. He provides SDKs and mappings for all the prefabs and configuration by providing another layer of configuration on top of that. Teleportings involves creating just a pointer and a Bezier renderer, adding that to your controller object. He creates proxies because when you're switching between Oculus and Steam VR, you can't actually use a game object for that. So you have to configure it on a separate game object in your scene. And of course, you can configure the way that those raycasts look. So it's not just like the one that you saw in the previous picture of what Arc Teleport looks like. You set up your play area with body physics, script, and height adjust. A lot of these paradigms rely on additive behavior. So on these proxy objects, you add components, configure them, and you need to double check that they're not using the same button controls because they're separate. They're configured separately. To grab objects, you add an interactable object to something with a collider, and so that you can grab it in a way that you expect. You add the fixed joint grab attach, which is one of the more common ways of doing things. Kinematic movement in VR doesn't quite feel right, and this is an approximation of something that feels a little bit better. That's a whole talk in itself, but it's really much more nuanced as you start to get into it. And these things are important, and we need to build on each other's work in a constructive way, and we're not all going to have enough time to make great experiences and do all these nuanced work. We want, ultimately, like, the default behaviors are good. Customizing can be challenging, and as you get different modality in your game and you expand it and change decisions, it can be, since it's scene heavy and you need to make sure that these components are configured correctly in a uniform way, if you map both things to the squeeze or trigger buttons, then what's actually going to fire is unclear. Configuration, you add setup really. Adding the VRTK prefab to your scene, which has a SDK manager. You hit a button, it'll scan for scene references, and it'll also add if-defs to your project. And that's an approach that works, and if-defs have a history that's worth noting. But the default behaviors are good. In many cases, when you're working in a short period of time, this is an excellent way to get going in making game jam games, and it's certainly I've used it for that purpose. Inheritance is used for extending its behavior. So things that are hackable rather than usable also have a history that's worth noting, but it's expedient, and this is a single guy making this. Like, support his Patreon. Like, anybody who's in this space, like, let's give him some love. The Steam VR interaction system, that has its own set of SDKs. It's used in the lab. It's basically Valve dog food some of their own software, and they figured out, hey, look, what are the most painful parts of the system, and how can we make that better? So they have a lot of features. They have examples from the lab, which are great. And one of these is sort of a core thing that you pretty much have to do if you're a developer, and that's adding a 2D debug mode. And I think that'll evolve, but that's a start. Ultimately, every iteration cycle counts. Every second matters. You'll lose your focus. You'll lose things pile up very quickly. So you want to be able to test what you're trying to do, and then get iteration. And the 2D debug mode helps with that. It allows you to click around in the editor and move around. To set this up, you take the player prefab, put it in the scene with a camera rig beside it, and you set the references yourself. And then it supports the 2D fallback. To create interactions, you add the draggable component on the items, and which is pretty straightforward, and the teleport and teleport point to set up teleporting. Teleport is basically a massive, which buttons do you use, and teleport point is what the destination looks like when you're about to teleport to it.
I'm going to quickly set up the room scale by doing the shortcut, which is, if I can remember, let's see, I don't remember. In developer or? No, I just wanted to, we'll just quickly do room setup. So I want to start showing you some demos.
Yeah, we've got demos of each of these, so we can show you hands-on what this configuration looks like. It's good to get an overview, so you get a feel of what it's going to look like. But certainly, the meaty details are where these things matter. These details matter. Okay, switch a slide. Unity has some. Oh, right, that doesn't work.
Yeah, sorry, I'm going to just quickly go through this, if it's possible. Headset. I wouldn't.
Yeah, it depends on what your background is. I think if you're primarily going to be a design shop and you're primarily comfortable dealing with the scene, it's a fine way to start. And you're probably not going to get into the nasty issues that you do when you try to do more ambitious things like redisplay information in a slightly different way, which is a really common task. I mean, you don't think about it initially, but you want to have an item, and then you want to be able to display in a store. And there's a lot of game configuration like that, where you're like, oh, I want a monster, and I want him to move around like this, and that can get unwieldy. You'll start putting scripts on prefabs and things like that, and that'll accumulate. And it has a half-life, but there's under-engineering and over-engineering, and you sort of have to pick what's right for you. I think that it's a fast way to get going. I think both these companies are trying to do what's best. I think they're taking a different approach. SteamVR is trying to fix the pain that developers feel the most, while the HEC, the Vive software, is they're trying to maximize upside. So it depends on what you really need. So ultimately, you want to focus on what features do I really need, not just what's available in these toolkits. Yes, you should do research on the market and figure out what things are compelling, but figure out what you need and then wrap it, use the correct tools. Ultimately, I end up writing facades and adapters for all this so that you don't directly access any toolkit, because all of this stuff is changing at a pretty rapid pace. And creating chain dependencies in Unity right now is not currently a very well supported workflow. I built a tool to help with that, but it's involved. It takes a lot of discipline. Basically, you're going to write something like Ant, Maven, or these other build systems. Hopefully not like Make, but I don't know. Let's learn from our past and do better. Oh, the IL to C++. There are, that makes actually dependency management a little bit more tricky because you'll have more release modes. There are, in a related sense, I mean, there probably are other people working on the dependency management problem. It's a well understood problem. Like I said, Ant, Maven, along with even distribution systems like Ivy. I mean, the JavaScript community took off after Node.js came out, and I think that the asset store has been a good place for an individual asset, but building on top of that generally has been fraught with some challenges. And we're sort of at that place with VR. Not only were we managing native dependencies with versions of Unity, dependencies of runtimes. Really, the last time this was a huge pain point was when Android controller support came out, and you just basically had to circumvent all of Unity. So I think there's and start using dependency management tools. And version of control is one aspect of that.
All right, let's just walk into the demos. So we're going to show a couple of scenes, each with a different toolkit. I'm going to show the HTC Vive input utility and how to set that up. So what we've decided to do, instead of the typical just grab some game objects and just throw them up there, we decided to take assets from the Tilt Brush SDK. So the nice thing about that is that it allows you to import your work from Tilt Brush, and it exports it and imports it as FBX. And the SDK provides all the shaders that you need, not for every brush, but for most of the brushes. And it's very useful for working with artists and to go straight into Unity quickly. One other example is their teleporting example is Little Maze, and we'll just actually show it to you when we run it. In fact, let's just run it now. Do you want to get in there?
Yeah, let's do it.
I'll run it. And
All right, going into another dimension. I'll see you guys on the other side.
Watch your boundaries.
Thank you. If only we had somebody to chaperone us through these experiences. That's the name of the holodeck thing.
Wait, let me start it again so I can do full screen. So Unity, maximize on play. There we go. And let me minimize this.
Oh no, I'm in a dungeon. I was in an expo before. So here you can see this is an arc teleport. This is a sort of simple example of what this visually may look like. But this gives me the expectation of where I'm going to go. And I can go look around. I can say, hey, what's going on here? And, oh, look, there's a keyhole. So what am I looking for? I'm looking for, treasure. Let's do it. All right. That's the key. This is not where I wanted to be. Nope. There we go. And
that's the keyhole.
Yeah, let's do it. So
right now it's not doing anything, but we can add that code. This is live coding.
Yeah, this is all stuff imported from Tilt Brush. It's that painting program where you paint in space. And it's an easy tool to start prototyping in VR and do rapid iteration. Even if you're not a 3D modeler, you can create 3D environments by yourself and use it like this.
So you do get the Tilt Brush SDK. Go to the teleport example, and the scene of the teleport example, but go to the assets that have the dungeon. And the only thing that we added, that I added here, was the key drawn in Tilt Brush and the keyhole, just to give it some kind of story and some activity. So that what we did was we tried every one of the toolkits. So this one, like I said, was using the input utility toolkit, just to show you the scene here. Maybe I can just zoom in so I can show you.
All right.
If I can zoom in, maybe not. In any case, so the environment and the scene are part of the Tilt Brush example. So player is part of this Steam VR interaction system.
This Vive rig comes from us, so it's primarily from them. But this Vive controller.
Right. So we already started mixing.
Yeah.
We'll talk about that in a bit, but just to give you the basics, there's a Vive rig that you drop in that takes care of the controllers. And you can see here in the inspector, there's a lot you can do with the controllers, and there's a lot of boilerplate. I mean, defaults for calling up a custom controller. A lot of these can be turned on and off. You can use it as layers of pointer. You can use it to teleport. For teleporting, all I did was to the floor, I added a teleportable script. All I did was just drag and drop that. For grabbing, there's a basic grabbable script, and all I did was just put it on the key, and that's all I needed to have this little story of walking around, teleporting, grabbing the key, and then using it. So we're going to now switch to the next scene, which uses
Demo 5 input, or
you just did
5 input?
I just did that one.
It's demo.
Demo VRTK,
Sure.
or maybe we should do the other one first, right?
Yeah.
Which one was that?
I thought it was something else, but I guess it's just demo.
It's just
this
demo.
Is Steam VR utilities.
Right. Yep. So let's run that one.
Okay, so this is Steam VR utilities, and they have their own system. They have some helpers where I can see, this. You can give users an in-context tooltip. Text is a little bit rough, but sometimes you got to bite the bullet because we're figuring out how to communicate information to users, and they're figuring out how to use the controls. So they provide some utilities for that, and they provide these waypoints where you can sort of warp around. And since I already know where I'm going, I'm going to go over here, find the key. And then go over here, and we're all good. Well, I can't teleport closer, but maybe I can. All right, yeah! It's the closest I've been to a sports star.
So immediately you can see some differences, right, with the teleporting alone.
Yeah, there's fixed waypoints. The way that you configure that is slightly different and a little bit more embedded. They're focused more on not creating a not bad experience, which you want to raise both the ceiling and the floor at the same time. I mean, if the other thing happens, that's bad. But ultimately, I think they're taking different approaches, and you'll have to use a little bit of each, and that's where using. Protecting your own game code from all these, because they'll be shifting rapidly, and you'll want to use the one that's best, and usually the smallest. And 5-input utility does actually have a lot of really cool code.
Their teleporting is very configurable. You can see it's a lot.
Like super clean.
It's a lot there. Yeah, you're getting, that's the most beautiful looking of all three, obviously. It's based on the lab, and it's good that they give you all these. Don't use the defaults, because then they'll know what you used. Just make sure you change this up, or use one of the other two.
Yeah, I think there are a lot of options here, and I think one of the other big sliders is that here you can see there's a lot of configuration in the scene. And this is fine for some experiences, but then it becomes more challenging when you want to deal with sets of things or want to globally change these. Prefabs are one solution to that, but as the whole nested prefabs issue at Unity says, that breaks down at some point. So you need to be able to structure your logic in different ways. I mean, you can always move things out to scriptable objects to stave off a little bit. But, like I said earlier, it's you got to weigh the, long-term engineering, short-term engineering to be able to, estimate where that intersection line is going to be in terms of cost benefit. And the final one is going to be VRTK.
I'll try that one.
All right.
You can talk.
Oh, okay. So VRTK is a very common solution. And fortunately, we have two versions of this scene. I'm fairly sure this is the right one. And, I guess he's in it, so let's go. All right. So you can see they define play area independently of whether... Is it... Nope. Try trigger? Okay, not the right scene. Fun with computers. 2 died in the making of this. You're kidding me. Yeah, that's a good idea. Thank you.
I'm kind of spoiled by the VRTK example. It's like you put your head to a wall and figure it out. They have these little things that you didn't think of, but they add so much. I guess we should create them a lot sooner.
Yeah, I think it gives you a good starting point to get a feel of how things work. And, I mean, it depends on what your riskiest assumption is. And in VR, there are a lot of risky assumptions we're all making. And we want to be able to figure out how to get there the quickest and test that out. And if your problem is related more to UX, then this is actually an amazing way to test that out. Or finding the fun of a core game loop. Yeah, Andy over there, we used that for Global Game Jam this year to make Bath Buddies an asynchronous sort of like shooter, where one player uses 2D, the other uses the 5. So there's a lot of advantages to each approach, and hopefully this equips you to better evaluate that for your project beforehand, before you get too deep. Were we slides? Maximize this again.
Just start.
Okay.
The Wi-Fi is slow, as you can see.
Wicked fast. Never buggy software, yes. So ultimately, what the question is yes, you want to weigh these things in terms of that, but you also want to think about systemic risk of like, how do these things iterate? How do they change? What are the organizations creating them and why they're creating them? That provides some context that you want to know. VRTK, he's solving a problem primarily for himself, which is an amazing way to solve problems. You're your customer, and you can create a lot of amazing things. 5-input utility is looking at how to make the best VR experiences in terms of like raising the ceiling and figuring out how do we make this better. And Steam VR is primarily focused on making the pain less bad. Well, making things better and making things less bad are on different axes, in my opinion. And so you start with, VRTK is top-down in terms of design heavy. 5-input utility is middle out for any Silicon Valley fans. And the Steam VR system is more bottom-up in terms of what their approach to solving these problems are. Because there are a lot of problems. We'll all figure them out. We all have to be able to rely on each other and build scalable systems that deal with the problem of, hey, look, these native libraries are changing, Unity versions are changing, and these other modules are changing, and we just need to take that on as a core competency rather than blame it on ourselves. These are organizational issues. These are systemic risks that we just have to be aware of when we're going into using any library. The Unity native plugins are starting to solve some of these problems as well. And this is where things get a little bit more muddy. It's exciting that they're making massive progress in this direction. They're starting to slowly integrate a lot of these features. Integrating them is hard. If you look at some of the decisions that are made in each of these toolkits, it's actually very difficult to wrap these at various layers because they're solving simultaneously for high-level, application-level problems, middleware, and native interfaces. I mean, all these systems have custom protocols talking to each other off of hardware that just got shipped. So this is a lot of fun, and we're going to have a lot of neat features for things like haptics. There's an iTool interface that actually uses a lightweight version of inversion of control to start to pick up some of those new capabilities and automatically integrate them just by the code being there. What's coming up in Unity 5.5 is this, it's already there. Sorry. So a lot of this stuff is now in there where you can get these nodes, these VR nodes, and you can find your head. I think they even provide a center eye because it was sort of a pain to constantly figure that out. And in rotations. You can query these. It's a little abstract. And it doesn't always give you everything you need, but use what you need. We talk about comfort. The Unity performance reporting is paramount for all of us because sometimes you don't notice a drop frame as a developer. I'm pretty immune. I can spin around infinitely. There are a couple people I've been beta testing, and maybe once or twice I've also written some bugs. And this sort of helps to identify when you drop below your target frame rate and tells you why, which is very helpful. Also, heat maps in VR are amazing. Use analytics. So coming soon are a lot more physics help. I briefly touched that physics in interactions is probably our biggest ally and worst enemy. Dealing with the rendering problems, it's sort of more well understood that things up close to you need to be rendered at high quality and far away, and we've used some of those techniques before. But for physics, we haven't encountered these problems at all. There are a few other toolkits we'd love to touch on, but also they're starting to solve some of those problems, but more and more you're going to see a lot about being able to figure out why collisions are not happening in the way you expect, visualizing that in VR, and of course getting more detailed dumps on why things don't happen the way you do it. Because ultimately your hand can pass through an object, your physical hand, with a Vive controller. Okay. So if I'm holding an object in VR and I pass it through the side of this, my physical hand can go over here, and I probably don't want to drop this controller until a certain point, just out of convenience. Otherwise, when I bumped into something, I would instantly drop it. There are a lot of those things, those cascade very quickly, so physics is huge. Integrated Daydream, more platforms just automatically getting rolled in, so you put it into Unity, you pop it out in another platform, as long as you build it in a scalable way. If devs being a big place where that can cause you some pain. They're giving you a lot more performance, Vulkan and better GPU instancing, and options where they'll reuse resources. They won't keep on pushing the same mesh 100 times to the GPU. They'll just use that same over again. Which causes fighting between the GPU and CPU. Dynamic and static lighting work better together, and of course, the other thing related to interactions is movement of AI is a lot better. So can you mix and match? I think the answer is yes. We experimented quite a bit with that, and I think we can continue to find paths through there, and I think we can build lightweight layers on top of that. And just from our learnings from this alone, there's some pain there, but ultimately that allows you, as a developer, the greatest flexibility to pick the best tool for the job, rather than just what you happen to inherit, because that'll ultimately cause you more pain. SteamVR, 5-input utilities, SteamVR.
Yeah, and the rest of these slides are resources and links. At this point, I want to open it up to Q&A. I don't know how much time we have, but if there's any questions. Well.
You mentioned the Vive utility 1.6, and you mentioned the Vive tracker is now available for
Yes.
On the back of it, it has the serial that has other inputs, right?
Yeah.
And they have a training, they have scheduled trainings, but I heard from this conference that there's a lot of documentation on that.
All the documentation is online for hardware integration and software integration, and the plugins, not just ours, the VRTK just announced support for the trackers. So it's good news.
This allows for real-life drinking games.
Yeah.
You mentioned physics. To muddle the waters a bit more, there's a toolkit that I'm currently using for physics specifically called Newton VR.
Mm-hmm.
It requires a little bit of poking around to get at it, but more than anything, it produces more realistic sort of physics. Our current project I'm working on uses a combination of VRTK and a couple of other things. But yeah, that's actually a really good way to get more realistic sort of physics as opposed to the just feel quite right physics. And then the other question I have is, how are your lighthouses at waist height and functioning on the HMD?
How is it working?
Field of view.
The field of view is large enough to pull that off.
Okay.
Since I travel a lot, I don't like to carry the long.
Well, no, I did exactly the same thing.
That's the only reason. I recommend over the head, obviously.
Yeah.
This is just travel kit.
Oh, and I mean, when it comes to, especially in a situation like yours, I think there are some easy solutions where instead of the recommendation for using both Newton VR and for VRTK is to extend that functionality and do that. There's another approach that is pretty lightweight and will protect you from changes in either system. You can create something that extends all those functionalities and extends all those functions and then expose actions that then reproxy that information, so you don't have to use inheritance. You can use composition in order to create your game functionality, which, I mean, if you value sanity, which isn't...
That's a hard one in going to really discipline yourself of composition over inheritance, where I'm C++ programming in my background.
Yes.
C# is like, oh, I get now PHP composition over.
Well, and this is an active discussion in the game development community that, I mean, if you look at the two major game engines, they take a different approach. I mean, one's hackable and one's usable. And I know it sounds like I'm biased, maybe a little, but it's a different approach, and it's frustrating for people to have a black box if you're used to hacking, and vice versa.
Yeah. And VRTK is a community. It's on GitHub. You can submit to it, and have a very, very active time.
We're going to have to end it now. We're out of time. Thank you, everyone, for coming. We're available for questions afterwards outside here.
Thank you all.